If the rope is 1,200 feet long and the parasail is 380 feet above the water, how far is the parasail from the boat? To find the distance from the boat to the parasail, you must use the Pythagorean theorem, which takes the height of the parasail squared plus the missing distance equals the length of the rope squared. This translates to 380 squared plus x squared equals 1,200 squared, and then this is simplified. The result is x equals 1,138. Based on the information given, what angle is the parasail at with the water? To find this, you need to use sine, which equals opposite length over hypotenuse. Plug in the correct lengths and simplify. The result is 71.5 degrees. Using the same method, we can find the other two angles. Based on the information given, what quadrant is the parasail in? Using the unit circle, we can locate where the right angle is based on the triangle formed by the parasail. Therefore, the parasail is in quadrant 1.
If the angle recorded between the boat and the parasail is 35 degrees, what is the complement and supplement of that angle? A complementary angle is any angle that makes another angle add up to 90 degrees. So to find this, we have to subtract 35 from 90. And when we do this, we end up with 55 degrees. And that is our complementary angle. A supplementary angle is very similar to a complementary angle. It's an angle that makes another angle add up to 180 degrees instead of 90 degrees. So to find this is very similar to how we found the complementary angle. We just subtract 35 from 180 and we end up with 145 degrees. And those are our answers. If the boat is spinning in a circle at 30 revolutions per minute and is 16 feet long, what is its linear speed and what is its angular speed? So we're going to start with linear speed, trying to find the linear speed in miles per hour. So to start, we have to multiply 30 revs over 1 minute, which is 30 RPM, times 60 minutes over 1 hour. We do this because 30 revs over 1 minute, it's in minutes, and it asks for it in hours. So we have to convert it to hours by multiplying it by 60. Then we have to multiply it by 2 pi times 16 over 1 rev. 1 rev is 2 pi times 16 because 16 is the boat length, and 2 pi is 1 full radian, 1 full revolution. Finally, we multiply by 1 mile over 5,280 feet because the problem asks for us in miles, but we're given in feet, so we have to multiply it by 1 mile over 5,280 feet because there are 5,280 feet in a mile. So when we do this, we end up getting, after you multiply everything, you end up getting, ooh, that is very big. That's very small. You end up getting 343 miles per hour. And that's our final answer. So then we move on to angular speed. Angular speed asks us to find it in degrees per second. We start by multiplying 30 revs over 1 minute, which is our 30 RPM. Then we multiply by 360 over 1 rev, which is we do this because 1 rev is 360 degrees. And it asks us to find it in seconds, but it's in minutes, so we multiply by 1 minute over 60 seconds to convert it to seconds. And we end up getting 180 degrees per second. And those are the two answers we have.